Hello everyone, I am Alan. Today we are solving it code number 1038, binary search 3 to greater sum 3, and this question is a immediate level question, and again that's another 3 related question. So let's dive into the description, which says given the root of a binary search 3 converts it to a greater 3 such that every k of original is changed to the original k plus the sum of all k's greater than the original k in the BCT. So give us a quick reminder here saying that binary search 3 is a 3 that satisfies these constraints. The left sub-tree of a node contains only nodes with k less than the node skip. Likewise, the right subtree of a node contains sonic nodes with k greater than the nodes k. Both left and right subtrees must also be binary search trees, so they give us graphic example here so we can see that the gray values here we have 4 on the left side, 1 and 0, so everything which is at the left side of 4 they are less than a 4, and that holds true for all the subtree to the left. Likewise, to the right subtree all values are greater than the root node, and that again that's also true for the full remaining of the tree. Okay, so the idea here is to update each node with the values of the nodes that are greater than the node we are in. For example, here we have this node here number 8, and then the parent is 7, but 7 plus 8 is 15, and again we go back to 6, then 21, because 15 plus 6 21, and we keep doing the calculation this way. One thing to note here is that tip that we can infer from the description here is degrade 3 such that every k of the original BCT is changed to the original k plus the sum of all k's that are greater than the original k. And if take a look at the right subtree, that's where we should look for the answer, because the right subtree is where the values of nodes are greater than the current node. So based on that, we are doing a work from right to left, and then that gives us a proper answer. Let's dive into the codes. Let me leave here the example. Again, we are going to use the diffs, which is a recursive approach, which is a really nice technique for solving the 3 problems. First thing here is we need some state, and I'm gonna create a variable called sum that's gonna hold the status of my summing. Next step is I'm gonna create a magic function called defs that's gonna do the full job, and then I'm simply going to return the result because we need to modify the original 3. So again, let's create our defs function. Root first thing is to finish our recursion. If root equals to no, simply return because you have nothing to do here. Next thing is to go right. We have to go to the right. Then we get right. Then it's gonna be on no. Then I go back to the nodes. Then I go back to the nodes, to the previous, to the node itself. That's going to be 8, and we say root val plus equals sum because we have to accumulate. So in this case it's going to be 0 here plus 8. It's going to be 8 again, and then we update the same variable. If root val greater than sum receives root of all, root of all. Now we know our sum contains and then we go back again. So but before that we have to go left as well. So this should do. Let's try running our code. That's work fine, perfect. One thing here that I'm just gonna try is we might not need that if looks good, because every time we sum are going right first, so the sum will always be less than the root value. Not we can try submitting our code, which works fine. So again, a quick recap. What we did was we simply updated the 3 values from right to left, from right not and left, updating with the sum of the values. We found that are greater than the nodes value, which they'll leave right side. Okay, thank you all.